Hello, welcome to this talk. We have a few people here in this auditorium, and we have recording going on. So we'll talk about SIG Node and what it's have for us today and what we're going to be working on in the future. First, let's us introduce ourselves.
Hi, I'm Mrunal. I'm an engineer at Red Hat, SIG Node tech lead and co-chair.
So my name is Chen, and from Google, a software engineer, and been in this project before inception, and for more than 10 years, I guess. Yeah, Sergey.
And I'm Sergey. I'm a chair of SIG Node and one of the approvers under mentorship of Don and Mrunal. I'm new relatively to this project, like only 4 years comparing to like 14 or 15, 20, some people claiming. Yeah, so with that, let's get into the meat of it. Can I turn the slide? Okay, so depending on where you are with SIG Node, you may imagine it differently. Sometimes when I'm thinking about SIG Node, I'm imagining this beautiful building and then somebody is building some DRA on top. But I mean, it really depends on where you are on this journey and how you see different components of it. Pretty soon, this like ugly thing on the top will convert into something very beautiful, and then next person coming up in the project will see everything as one monolith, one beautiful building. So, but what we'll be talking about, we will discuss what is SIG Node, what we own, and what kind of we building here all together, and then we'll discuss what we recently built. And finally, we'll go into future, what we're going to be building, what kind of trends we see, and what challenges we need to respond into SIG Node. So, introduction to SIG Node. Many in this auditorium knows what SIG Node is, but it's never too much to discuss what we're doing in SIG Node. So, like, in SIG Node, like in the past when we've been drawing SIG Node, I mean, SIG Node is all about what happening in a node. So imagine you have some containers you need to run, and some scheduler decided to put it in specific, scheduler decided to put it in some container ships, and every container ship is a node, and this node decides where exactly to put it, how to put it so it wouldn't fall off, or like if it starts burning, we'll throw it off the board and continue running. So in the past, when you draw this picture, you have a container runtime as an engine, you have Kubelet as a manager of this engine and something else. Nowadays, you need to draw more pictures. Like now, we're talking a lot about AI/ML, we're talking a lot about extra devices. So Kubelet by itself already not enough to manage all those devices. So we have plugins. Today we have two different types of device plugins, device and DRA, and we have CSI plugin as well for complexity, and we also have some monitoring on top of it, like an NPD. So yeah, to reiterate, like SIG Node owns all the components on Node, and those components are some pieces how we iterate with, like Kubelet as a main component, and then components we iterate with is container runtime. We also iterate with some resource management. We do it inside Kubelet itself and outside as well. We have device plugins for big devices like accelerators or networking device. We have monitoring, like node problem detector. It's more of a watchdog than monitoring. We have different monitoring solutions as well. We all don't own them too much, but we own everything that is, all the telemetry is going outside of Kubelet, we review it. And then storage and networking components, how we operate with them, how we pass some callbacks, and how we tell them what's going on a node. So all those components are owned by one SIG, and you can imagine it's like such a huge set of components and huge number of people working on all of that. And it's all needed to run everything efficiently, run everything great, but it's all on the same node. So right now, we can optimize you, but we can only optimize to what we see on the node, and cannot optimize beyond that. For optimization beyond the node, we have higher level components. And then you can imagine like this such a big set of components and ownership we have a lot of things happening right now. We have 5 working groups now. It was 4 last year. We have 11 sub-projects. We have, just sheer participation in our Slack channel, in our email list. We can reach a lot of people interested in SIG Node by just being there. And then CAP-wise, we are leader of CAPs. Like CAP is enhancements that we do in Kubernetes. SIG Node is a leader across the board. It's like not even distant second. I think second place, maybe 5 CAPs. So like we're running on double digits for a long time already. And you see, every release we need to review and track some 36 CAPs, and then out of them, some of them will be tracked, some of them will not be tracked, and out of them, some of them will be implemented, and some of them wouldn't be implemented, and we need to reiterate again next cycle. But it's a big number, and if you participate in and you just bring in something in, just remember that there are so many things happening simultaneously that you just need to bring a lot of attention to us to make sure that your CAP is also moving along. And yeah, if you just watching what's happening and just watching PRs and issues being filed for SIG Node, it's just a huge number. And we have meetings, we have 2 meetings every week, one for triage and one for just overall what's happening. And the triage meeting is 1 hour of basically triage. All we do is looking at what's happening and how we can improve the project. So that's a lot of things happening, and with that, I want to pass to Dawn to explain what we're doing right now, what just happened.
Thanks, Sergey. And today, I've been so excited being here and together with the Mrunal. And I'm going to show what we have been done. And if some of you guys went to the KubeCon this year, Europe, this year earlier, I remember I announced, I said, okay, Kubernetes is going to shift from the node focus to the workload focus, right? So whole Kubernetes also will shift to that, and the node played a critical role there. So that time I promised several features, I remember, and today is the chance I come here to report back to everyone here and what we have done, and some of those important features. Right? So just like Sergey mentioned that Kubernetes SIG Node always is the top 1 or 2. Actually, I think always top 1. There's no doubts. And the top 1 have the most of the feature development, most of the CAP tracked and development over each release. And you can see that in the 1.32. And one of the big focus for SIG Node, it is give you more the power and flexibility for the resource management on your Kubernetes cluster. So you can see that from this table highlights all the key functionality, key features we've been development over this development cycle, and the range from the alpha to the stable, and on the variable areas. And in this release, we actually made the improvement on the device, special device management, and also the dynamic scale of the resource based on your workload needs. And also we even leverage of the swap memory for the better resource management and all those kind of things. You can see that. Okay, first let's celebrate some of the major milestones and some of those in this release. And we have the 2. Actually, there's the DRA also, and but it's not included here. But the first let's celebrate of the stable. So there are 2 features. One of it is we introducing about the sleep action for pre-stop hook, and this is graduated to the stable. This is simplify a lot of the graceful shutdown and experience for customer, for the users, and avoid of unnecessary complicate of the customer scripts and also the workarounds in the system. And another thing it is we finally graduate of this dynamic sizing the memory backed one to the stable. And this is actually the feature help the improve of the utilization. So you can can dynamically adjust about your well-known tempo effects, such as those kind of things, and based on your pod limits. So this is super useful and improve the overall utilization and all those kind of things. Another thing it is we have the 2 features, actually more than 2 features, but it's not listed here. And listed here is the 2 features. One is the pod, in-place pod recessing, and it's going to finally, after 5-6 years hard working, debate over, and also in the 1.27, it is alpha, and now finally it's beta in this release. And so I'm going to talk about more about this one later. And then we also have like the support to drop in Kubernetes config directory, and this is make management much easier. And so then you can see that on this table, there's the many of new alpha features, and include about the toning about the crash loop back off features. And this is really critical for a lot of workload, especially for AI machine learning workloads. And we are going to continue to improve this one. And yeah, so please try those features and give us the feedback and the inputs and complain if it doesn't work for you. So let's dive into some of the really most impactful features in this release. And let's start from the most popular one, most famous one. And the lately is the device resource assignment, right? Previously called dynamic resource allocation, or DRA. So you can think about the naming history. It means this is complicated, and also history, we have non-history on these features, right? So before DRA, and so the management of those special, let me start exaggerate this, okay, first. So this feature, actually, I really think about this game changer for a lot of, for anyone running off the special workload. And those workloads actually using the those special hardware, like the GPUs, TPUs, and also customer network device, right? So this is a little bit exaggerated maybe, but that's what we believe. So this is why I put a lot of effort on this one. So before DRA, okay, so to manage those kind of special devices is really complicated, and it's hard management. And so with the DRA, introduce a standardized of the framework and to manage those special devices, which is simplify the overall pipeline and the overall of the cluster operations, right? So one of those key things is DRA. It is allow those driver, those special device driver expose their resource while structured format, structured way, and which it is make of rest of the world ecosystem, and is to utilize those kind of things much better. For example, and in this release, and the DRA is getting even better because we graduating of the structure parameters for those special devices to the beta, and add enhancement for the scheduling. To utilize, leverage those structured parameters, actually there's a huge improvement of the scheduling and the scheduling. We are talking about 16 times faster of the scheduling. So this is make of this feature, small part of this feature, it is GA. Not GA, sorry, beta. So, and also in this release, and we are allowed the driver-owned, introduce of the driver-owned resource claim status. This particularly feature is really important to enable of those advanced multiple networking use cases, those scenarios, because we actually allow those device driver can have more control about how those network device is being allocated and used. So this is give them grant of them more flexibility, more power, and then another thing we make of huge progress, it is integrate about the DRA with the cluster auto-scaling. Thinking about, and now you can auto-scale up your cluster and with those special devices and expensive devices, and based on the need about your workload, right? So it's instead you are provision those kind of things and statically configure your cluster to support those jobs. This is particularly useful for those serving jobs, right? So, and on the other hand, it is the ecosystem to using of the DRA actually is booming. And there's the example driver and NVIDIA GPU drivers are production ready. And you can try with those kind of things. And also the CNI and the Google TPU driver is under development. And more those kind of things will coming, and please just help us to polish all those kind of the API and add the driver and build this ecosystem. There's also have the more roadmap, and Patrick and John and Kevin, who are leading this effort, actually have the several talks in this KubeCon, and please follow up those kind of take a look if you have more interest. And I steal this slide from Patrick's talk. The reason it is so people can navigate through, because it's no different from the previous, what I'm talking about, benefit and all those kind of things. But you can click all the links if you want to know the details, design and implementation and the testing status, all those kind of things. Go just. Okay, next up, it is one of the feature also for years, in-place pod resizing, and finally better. So this is in-place pod resizing. Actually, it is allow you dynamic the scale, adjust of your pod resource allocated for your pod on demand based on the workload nodes, right? So, and also you can adjust their resource and without avoid of unnecessary of the downtime for and service interruption. So this feature, we've been developing this feature for years, sorry. And this is one, the feature itself actually gives you the workload elasticity and make them, it is adapt to the workload change dramatically. Think about some of the workload is running smoothly all the time, and all of a sudden, and experience some increasing about surging, some of the resources surging during some special event or all the other things, and you don't need to readjust about the CPU and the memory and put them down, and actually you can dynamically adjust, in place adjust those kind of things, make this continue running, right? So this is really powerful things, and because doing this kind of things, and then we are actually allow you even more optimize your resource allocation and utilization, and reduce those waste and expensive of the compute power waste. This is actually direct translate to the dollar saving, right? So the cost saving for your workload or for your cluster. And of course, the last one, it is this one actually give the possibility you can dynamically correct of the resource misconfiguration without downtime, right? So shutdown of your those things. So anyway, this feature, it is the win-win all around. And so for this one, so please try this feature in your testing environment and give us the feedback. We are improve those kind of things. I got this last night. I got this spreadsheet, and because I proved last PR just yesterday, and then last night is merged finally. So then I can see it is better. So same idea, so you can navigate through. You can see this is what we are doing during the 1.32, this time development phase, and we have so many of the things. This is not all, actually, but major change all included in this screenshot. Now, let's move on to the new features, pod life resource specification. And now it is alpha. We start I talked about these features like many years ago, I remember. But we never really committed to doing this. Even we introduced pod level C group many years ago, and we introduced after pod overhead, but we never really get around to commit to do this. Finally, it's here. So this feature basically it is allow you instead of define, assign the container, each individual container resource requirement. So we allow user to define resource requests and limits for the pod as a whole, right? So then you don't need, it is reduce of simplify the resource allocation, simplify the, get rid of those complexities to calculate of the resource requirement for individual containers, right? Just think about, this is especially useful for those complicated pod which have tight coupled several of the containers inside one pod, and they may be experienced about traffic peak at a different time, and then actually you can put them together and assign about the pod level of the resource. Need container dynamic to figure out how to best utilize the resource assigned to the entire pod. Of course, this is the same as the in-place pod resizing. They are optimized of the resource utilization and reduce the waste, right? So you can charge, actually you can charge the real usage based on the pod usage for the customer. This is also kind of like have those some cost saving benefits for the users. So, and like what I say, think about the application, have the tight couple of those services. And just like, for example, imagine e-commerce, those resource and doing of the shopping session, and so how you are going to manage of those kind of things, and also like the streaming services, how you are going to manage those kind of things, and this is basically give the flexibility to how you adapt to change your workload based on the different type of the nodes over the times. So this is alpha, and the feature itself is super useful and powerful as its own, but to think about together with in-place pod resizing together, this is even more powerful, right? So you are not you need not just individual of the container. You can adjust about this shared pool of the resource and the need container based on those kind of the services. So, so all those kind of things is. So last one, let me talk about the node swap support. And we've been developing this also for years. Traditionally, and the Kubernetes community, especially SIG Node, especially myself, and really uncomfortable to introduce swap into the system, because just giving uncertainty, giving off the performance, and giving off the unpredictability about for the workload, right? So, and this is really hard. But we also cannot ignore the valid use cases, right? So for swap can enable, especially for those VM. I think the VM container use cases, and and also for the booming about like the stateful side workload at this time, you cannot that increase of the resource on the giving node, especially for those biomedical use cases, and you cannot dynamic add more resource and to the physical node, and but you are temporarily suffer about of the memory spike, right? So what you can do, so this is why actually add this kind of add extra buffer to your system and allow those kind of workload to handle those temporary of the memory spike and more efficient instead of evict them and kill them, all those kind of things. So this is why we are committed to doing this one. And so we proactively work on this one, and the team actually conduct of the extensive of the stress tests to make sure this work based on what we are expected and meet our performance requirement. And one of the challenge, which is actually make us not promote this to beta, it is just figure out evacuation management integration, right? So we want to still make sure improve of the eviction manager and make sure there's the job using of the swap and avoid of the swap situation, and also protect the node, prevent node from the instability, those kind of things. So, but this is a high priority. So we're hopefully next time I report back, this is already beta or GA. So yeah. So now I'm going to hand over to Manu for other things.
Thanks, Don. So Don covered all the big items that are happening in SIG Node, right? So we want to make sure we also highlight the smaller improvements that still improves the life of a Kubernetes admin or a user. So here are a few KEPs to call out. So first one is for allowing special characters in environment variables. So previously there was a limit on what characters you can use, but now it's been expanded to cover all the ASCII characters except the equal to. The second one is about splitting standard out and standard error log stream. So in some cases, you may only want one of the two, and this KEP is working towards making that possible. The third one by Akihiro here in the audience is for improving the security. So if you have mounts and sub-mounts under those mounts, in most cases, you want to make sure that when you make the top-level mount read-only, you also want the sub-mounts under that mount to be read-only. So we introduced this KEP to add that feature to make Kubernetes more secure. And the final one is when you're using CPU manager and you're using guaranteed pods, your burstable and best effort pods can still go and use up your reserved CPUs. Now this can interfere with your kubelet or your other system daemons, right, which is bad. You want a clear separation. You want to protect your system daemons from your workload pods. So this KEP isolates those CPUs just for the system, and the burstable and the best effort pods don't interfere and run on those CPUs. All right, so Don covered the motivation for introducing pod-level resources. So I'm going to go a bit deeper into that, into the implementation of how it works.
So while Mrunal is switching off to, you want to talk about first?
Yeah.
Okay. I just wanted to mention a couple things. Like we're talking about a lot from user perspective, like what user feature we enabled, what we did for users. But from maintainer's perspective, if you want to contribute and you interest what happened, we didn't put it on slides. We did a lot of work in testing, for example, in this release. So we started doing error injection and CRI testing. We did error injection device plugin testing. We introduced systemd watchdog for Kubelet. So we're doing, like, beyond all the user-facing features, there is a lot of happening under the hood. So if you're joining us, there is plenty of work for everybody, all different sorts of work. Yeah, sorry about that.
Thanks, Sergey. All right, so going back to pod-level resources. So this allows you to specify resources at the pod level. Like today, typically you specify your memory or CPU limits or requests at each container level, and then they are aggregated or added up at the pod level. So now with this KEP, you have the ability to just specify the values at the pod level, and your containers can now work within that threshold. And this can work out in cases where all your container resource picks are not hitting at the same time. So you're basically, you have more capacity on your nodes. So one thing I want to call out is this is entirely opt-in. This doesn't take away the existing feature where you specify things at the container level. You can do that, and you can mix the existing container level limits with the pod level limits, and there's a whole table on how it works. So the initial support was added for memory and CPU. It'll be expanded for other resources. Also, this is going to be C groups V2 only. So if you haven't already migrated to V2, please migrate. This is like carrot for getting folks onto V2. All right, so there are some rules for specifying pod level resources. Like no individual container limit can exceed the pod level limit. The pod limit, if specified, must be less than or equal to the sum of individual container limits. And then if a pod request is specified and the container request is specified, the pod request must be greater than the sum of the container resources. This fits in the mental model of how the container level requests and limits work today. So now we can look at this, but what will be more interesting is looking at a live demo. So the code is fresh. It just got merged, code freeze last week. Let's see if we can get working here. All right, so I have a Kubernetes cluster up with the pod level resources feature gate enabled. So this is how you would specify container level resources today without this feature, right? Say you have two containers, an HTTPD container and a Redis container. You give 100 megs to HTTPD and 150 to Redis. And this is how it looks with pod resources. So instead of specifying individual container level numbers, you just specify them at the pod level. Now let's try running these pods. Okay, so we have both the pods running. So first we're going to go and inspect the old style pod. All right, so this is the HTTPD container. Let's inspect the memory limit. It's 100 megs, as set in the spec. Now let's inspect the Redis in there. Redis is running. And it has 150. And at the pod level, it should be 250 if we go and inspect that, okay? But now I'm going to switch to the other pod. So we are in the Redis container. And if we look at the limit, cat, yep, thanks. All right, so it can go up to 250 because that was the pod level limit. Now inside the HTTPD, it's also 250. Now we're going to wonder, isn't that adding up to 250? But wait, that's not the full story. We'll go back. We're going to inspect the pod level C group. So from here, I want to get the name of the pod. It's pod BB2CA. So we'll go to QPods, BB2CA, and here, if we do a memory max, it's again 250. So now the pods can individually all go up to 250, but pod as a whole is restricted to 250. as long as they're not hitting the 250 at the same time, and they are like adding up to 250, then this works out. So this is like a short overview of what this feature is about, and you can still like mix and match resources and limits at the container, at the pod levels to make it work for your use case. So now I'll hand it back to Sergey.
I think we're running out of time here, so I will try to be brief and try to tell you what is happening right now. So what we see and what we're working on in SIG Node is it time up? Yeah. OK. So we're seeing more and more workload-centric improvements rather than not infra-centric improvements. So we're talking less about how we get infra assigned to pods. We're thinking about how this pod wants to consume the infra, how this pod wants to consume the resources. And we found that, I mean, this is like Houston, we have a problem moment happened when we have more and more frameworks like Kubelet in this picture having a thing called node pod. So, or pod node. So pod that is actually a node for them, and they schedule something inside this pod. So now you remember, like we are node team, but now we hosting small pods, and each pod has, like maybe big pods, but each pod has an orchestration inside this pod. So each pod becomes an individual node. You see similar picture in VLLM right now. So we're working on a thing called VLLM instance gateway, and this gateway routes traffic not to pod, but to use case, to LoRa adapter inside this pod. So pod now consists of large model server, small LoRa adapters, and then instance gateway is directing traffic to these use cases rather than to entire pod. So pod is no longer the unit of what you deploy. It's not a unit of what you orchestrate. You orchestrate something inside the pod now. And we see more and more use cases like that. And this is definitely a trend we want to address. And you heard this, like pod level resources is attempt to step into this direction. We have vertical auto scaling, another like things that Don was talking about is also step in this direction. And we have more and more improvements like that to optimize for those scenarios. So we wouldn't have node pods any longer. We will have something that Kubernetes know about and can help orchestrate. And then other trends we see are all related to devices being extremely expensive now. So we have solutions for every workload. Like every workload you have, like something failed, just recreate it. Like start from scratch. Like get a new node and like create a new pod on it. But if you're talking about expensive device that is cost like a lot of money even per second, then you're talking about like minutes of downtime, and then some jobs like training jobs involves many nodes. Like so to run one big training right now, like I mean hero training, like big one, you need like hundreds of nodes. So hundreds of nodes needs to work simultaneously, and if one of them is lagging behind, you're losing performance on all of them. So like multiply single node being out of rotation to this hundreds of nodes, and then neither of these nodes can make a progress because of this one guy. So we see more and more situations when pod becomes that very expensive and very cherished resource, and you don't want to build or break it. You don't want to unallocate it and allocate it on different place because it's super expensive. We see it more and more. So it's not cattle any longer. Like I don't know if you remember talks from early Kubernetes, like don't look at your container as a pet, it's a cattle. You can kill it, you can recreate it, you can scale it. Now it's not the case any longer. At least for a while, we'll have super expensive devices and everything will be very expensive, and we'll need to start looking at pod as a pet. And then dynamic pods, I just discuss this, and we have many things that contributes to that, like even DRA that we're working on. In the past, device plugin, that would interface that we come up a long time ago, it was assigned to containers. Now DRA is assigned to pods. So some resources you assign to pod rather than individual containers, and then containers inside the pod can share this resource. So you orchestrate in pods, but then like pod orchestrates resources inside itself by sharing this resource among containers. And in the beginning, I also said that we only look at node as a unit of information. It's very simplified view. Like if you only care about what's happening on a node, you kind of living in this like small little world, which is nice and happy, and you don't care about scheduling, and like you just make a decision, tell me what to do. That's not the case any longer. So we have more and more devices that interconnected between nodes. So node needs to know which GPU to allocate this specific pod, because this GPU is connected to that GPU, and you need to know that they need to work together. We have more and more scenarios when pod is not a unit of deployment, and in fact there is like things like LWS, Leader Working Set, is a new controller that will allocate multiple pod all together, and they can only work when they all work. If one pod failed, every other pod is also not needed, and it's a totally new scenario for us. Like now, you need to think about how you kill pods very efficiently, very fast, so they will be recreated all together on a different system, super fast, without all the graceful termination and like possibility to get delayed and stuff like that. And gank scheduling is also the same. So if you have a training job, you need to schedule all of them together. How do you make sure that you have enough? Like, let's say you want to schedule 512 pods, how you make sure you have enough resources everywhere pre-allocated so you can schedule it, you don't have any delays, you don't have anybody lagging behind. That's all very important, and it's all in the future what we would want to solve. And now, if you feel that it's an engaging area, or just in general, I wanted to spend a little bit of time to explain how you can get engaged. So we cherish any contribution. Sometimes it's harsh to contribute to Kubernetes because bar is very high for every contribution. But if you're serious about it, we welcome and we help everybody. Our favorite contributions are improving test coverage, fixing bugs. Our favorite but expensive contributions that we really want you to think about your commitment ahead of time is feature contributions, and feature implementations take a lot of time, and if you want to commit on that, we want to know that you're serious about it and you are not just passing by and like you thought that it may be a nice improvement and you're not ready to spend enough time on that. And then code reviews is also always welcome. We don't have enough reviewer power. And with number of caps we drive in every release, it's very important. And then there are plenty of non-coding contributions. We all busy people. We need to make sure that everything is taken care of. Like, and we have so many pokes from SIG docs, from how we run our meetings, how people need to get information, annual reports that we need to publish. All of that requires attention, and if you want to help with that and you're not ready to start on code contributions, we also welcome that kind of contributions, and we have a place for that for sure. And then why SIG Node? I don't know if you're convinced yet. It's very serious SIG. Get involved here, you'll be involved into everything happening in Kubernetes. Everything touches Node, everything other SIGs wants to do comes back to us, and we will work with every SIG. So if you want to work on fundamental of Kubernetes, SIG Node is the right place. We have a lot of opportunities from very small to like extremely large, and you may notice that it's a turmoil time. Like we have AI/ML coming, we making pods dynamic. I mean, I haven't even thought about it a year ago. Now, like dynamic pod is normal for me. And then communities are amazing. We have so many great people. So you just get involved and you allow it. And there are a few links how you can get engaged. We have many working groups, many places you can start with. And with that, I want to thank you for having been here. And if you have any questions, please ask. And this is a feedback link.
Guys, thank you for your presentation and for amazing features you provided. It's really awesome. And my question is about, well, resources for a pod, like shared resources. Well, imagine the situation in pod, we have like two containers which are kind of application containers, and third container, which is kind of observability container, which provides metric, etc. And will we have opportunity to like set the concurrency behavior for these containers? Like all these containers will concurrent for these resources, and how we will be able to handle it. Like the same process we have in Linux, kind of nice CLI, which could handle it in terms of processes. I think, if you understand my question, thank you.
Can you summarize one more time your question a little bit?
I can try to answer, but tell me if I'm going the wrong direction. So what you're talking about is a big pod, and you have a sidecar for monitoring.
Yeah,
that is
for
less
example,
important.
in pod we have a lot of containers, and how we can actually deal with this concurrency in container. For example, one container will have a desire to consume all resources in this pod.
Totally. So actually, I can try to attack this question because earlier I talked about both in-place pod resizing features, right? So, and also I talk about the pod level of the resource. I did oversimplify the things. Actually, the feature will be even more powerful. And so in your cases, what you're talking about, right? So this is why I talk about itself, individual things, and it is a powerful feature, but the combination together actually is even more powerful. And you just give me a perfect example here. So you already have the application container, and maybe you already do those due diligence to configure about how your application container for the resource limit and the request, right? So then there's the sidecar container, for example, you are using of the services mesh, right? So the inject of sidecar container, and all those kind of things, everybody go crazy right now, sidecar container, right? So some of the sidecar container, they also specify about you already upfront knows the resource limit for those kind of things, right? So you could, this pod level of those kinds can be some of all those kind of things. And at the same time, also have the additional buffer based on those kind of things. So all those kind of things could be dynamic, configured by the system, right? So the people injected, you enable certain services, for example, services mesh, and inject of the sidecar container. They also could, because we also have the dynamic, the in-place pod resizing, could be add this additional about adjust of the pod level of the resource, just allow those sidecar container being injected. Right, so, and another thing it is, earlier I mentioned that, I said, oh, please try those features and tell us the input. This is for real, it's because I only talk about you could share, your container could share about the resource, like you can not set of the resource limit and request, only have the pod level. Then let them be to dynamically figure out how to share, right? You also could pre-configure some of the application container to tell of what's the request and what it is the limit. But at the same time, you give the additional buffer and need several of that, not that important, best effort of the container, but have to run in your pod to share of the rest of the code. So, but the problem it is right now, we haven't figured out. This is literally, engineer ask me, say, Don, which one we can do, right? There's the two use cases. One use case is we could leverage off the C group kernel, right? To guarantee one of those containers and always have the higher priority to access those resources because you do good job. Quality of the services today only on the pod level. I can go even further, right? So I can even go to the eviction management. And what it is with management is the pod level and go deeper to the container level, right? You can tell me scheduling level. So we can do, but this is one of the use cases, right? So a lot of use cases, it is, you could say container, you have this release, this resource limit and say, we are jail you. You cannot use more than this. And the rest of the pod resource, or maybe entire of the resource can be used by other container. So they are burstable, they are important. This is why I ask some feedback to us, because this is an open question. And on purpose, in this alpha, I told engineer it's not to solve this problem, okay, because we need more to understand, right? So we lower down the scope. Anyway, just share with you. Hopefully, I answer some of your questions and try this and then give us feedback. We definitely, because it's alpha, and also another feature is beta, so definitely not complete, perfect, right? So, but we are working toward that. Yeah.
Okay. Can you hear me? Thank you for the presentation. Have like a question. You mentioned stuff about pod is not a unit of orchestration now, becoming not a unit of orchestration. And to be honest, it sounds a little bit scary because like for a lot of years it was like this is unit of orchestration. That's how we think about it. And now
Can I take this question?
It's all changing, and like I said, like it's a little bit scary. I just hope that, and all the examples you mentioned were also about AI, but there's also not just AI stuff. So I hope like AI doesn't steer everything into direction where it's like a bit too overcomplicated, and maybe like some features might be built into Kubernetes, maybe some left for like third-party things like Q with a K is like for managing this like Q resources and stuff like that. So I'm sure you're doing a great job. I just hope like this is like taken into account. So like in 5 years we don't look at it and say like, oh, it was wrong direction. We overcomplicated everything. Thank you.
Maybe I answer this question. For dynamic content. So thanks, Sergey actually introduced this one. I'm surprised to me. I didn't realize the slide deck later after. So I have this proposal. So I published this proposal. I have these things for years, and until recently booming of the generative AI and the batch workload, and make me think about I have to talk about maybe this is the future direction we are going. But on the other hand, I just want to clearly say that from day one, Kubernetes design, I insist pod is the minimum scheduling entity. It's not execution. If you really see that, this is why we introduced container runtime interface. And container runtime interface is not using pod as execution, smallest execution entity. And because Docker don't feel like that way, right? Docker using a container. Docker is the only product ready container runtime. And also, not just that, also there's the policy, Kubernetes policy, and evolve. Constantly evolve until after 10 years, we are still constantly evolve. So that's why I add the node level or add like a data plan level. And from day one, I mean, yeah, it is from day one. So the pod is the smallest scheduling unit. And for Kubernetes scheduler, level it is an execution unit. I try to correct this for years. So what dynamic pod, actually still pod, it is the smallest unit, scheduling unit, and for the Kubernetes at the cluster level to placement, right? So the only things this one, it is allow hierarchical scheduling, right? So all the existing of the features, you want to schedule static pod, still work, all those kind of things. Instead, it's just we allow the sum of level of the dynamic pod, and so you can allow some of the batch workload, like the Ray, like the Slurms, like many other. So, and people build today, they can after those pod placed on the node, right? So based on those whatever policy or whatever the hardware or device connected to those kind of things, and then workload will schedule their task, which is container here, into those group of the pods. And they will know, because workload, the batch workload knows more the dependency. They want to do finer grain of the resource management. They even know, for example, there's something like we are talking about the DRA earlier. I'm talking about we introduced of the status, claim of the status, right? So those multiple network, advanced network scenario, we need to support those kind of things because they understand which how the allocator of those network protocol connect to two node, and which container, two container maybe, or multiple containers, and need contact using those network protocol connect with each other. So all those kind of things, we just incremental a number of the more powerful possibility and capability for different type of the workloads. But existing one, we are enable for stateless workload or stateful set will be same, and only I guarantee we are put more effort to resource management. Hopefully we can improve the overall performance for those workloads. That's all. Hope I answer your question here. Yeah.
And I also want to assure you that, I mean, Kubernetes goes into waves. Like when I joined 4 years ago, it was like in the bottom of reliability. We had so many test problems, and pod lifecycle was having problems just because we introduced a lot of features before that. And now we kind of on a high point when we very good quality, everything's stable, and we have a lot of tests covering stuff. So now it's kind of every step we do it in, like Don said, it's every step is incremental steps that we heard feedback before. So it's not just AIML, it's just feedback from past years. We just taking these steps now. And there are a lot of steps together that will help those kind of scenarios that we've been talking about in AIML. Thank you.
Thanks for the wonderful question.
Next, one more question. Thank you for the presentation. We have a use case that we need to manage the local SSD disk. I wonder whether we should use the DRA to handle it, or we should model them as CSI, or we should do both.
I think it really depends on how you intend to use it. I don't think there are currently any efforts to mix CSI and DRA. There's a CNI and DRA work interest group that's in progress, but it'll be worth exploring. So what we have going on is the split disk stuff, so where you can spread your stuff across. You can have your logs on one disk, you can have your main root disk on a separate disk, you can have your container images on a separate disk. And work is going on to make sure that the kubelet recognizes these configurations and handles them better.
Yeah, I think one deciding factor maybe for you that DRA may help you allow to specify and configure it such a way that pods will be scheduled with some common properties between disk and GPU device and some other networking properties. If you have device that is CSI disk that is very special and you want to match it to some other NUMA node or some environments, then DRA may be a better choice, but I think CSI is typically what you're going to use.